In this video, we're going to learn about conditional probability. So first off, conditional probability, this is called Bayes' theorem, and Bayes' theorem says that if we have probability of B given A, this equals the probability of A and B over the probability of A. So we're going to use this and apply it to this problem. So this problem tells us that in a certain region, 1% of people are drug users. And if someone actually does drugs, there's a 99% chance they will get a positive test result on their drug test. If they didn't do drugs, there's a 2% chance that they would still get a positive test result. What we want to know is find the probability that someone does drugs given they got a positive result on the drug test. So when you're doing these problems, the first thing I like to do is to make a tree diagram. So we're going to visualize what we have here. So first off, we have 1% of people are drug users. So either you're a drug user or you're not a drug user. So I'll just call that D, and we'll say not D. So 1% gives us 0.01. So 0.01 drug users. If 1% of people are drug users, that means 99% people are not drug users, so 0.99. So now, when you take your drug test, there's two options. You either get positive result or a negative result, and that works if you actually do drugs or if you don't do drugs. So I'm going to put positive and negative. Now it tells us if someone actually does drugs, so we're looking at this top branch here, there's a 99% chance they get a positive test result. So given they did drugs, 99% chance it's positive, so 0.99. That means there's a 1% chance that they get a negative result. They get away with doing their drugs and doing the drug test. If someone doesn't do drugs, so looking at this part here, there's a 2% chance that they get a positive test result. So 0.02, meaning 98% of people, if they don't do drugs, then they get the negative test. So now that we have this all written out, we need to figure out what we want to find down here. So we want to find the probability that someone does drugs given they got a positive test result. So what we want is the probability that someone does drugs given, remember that line is given, they got a positive test result. So we're going to put this into this equation. So this B is now a D for drugs, and the A is now a positive. So we want to replace all of those in the equation. So this B will become D, the A is a positive, the A is a positive. So rewriting that here, we have probability of D given positive is the probability of positive, and they did drugs, over probability they got a positive test. So now we need to figure out what these are. So if you remember from our multiplication rule, whenever we see and, we're going to multiply. So we have the probability of drugs and the probability it was positive. So we'll multiply those together. So we get 0.01 times the 0.99, and that's the top of our equation. So those are the people who did drugs and they got a positive result. Now for the bottom, we want all of the positive people. So we already found the people who did drugs and got a positive result. But now we need the people who still got a positive result, but they didn't do drugs. So these people still got a positive result. So we need to incorporate those. So if you remember, for our or, we add. So the people who did drugs and got a positive result, or the people who did drugs and got a positive result, is going to be what we found for the first part. So this is our drugs and positive. Or it could be the drugs and negative. So it can be not drugs and, sorry, not drugs and positive. We want all the positives. So on the top we have our drugs and positive. On the bottom we have our drugs and positive or the not drugs and positive. So all of our positive people go on the bottom. So now we can do this math. We have 0.0099 over 0.0099 plus 0.99 times 0.02 will give us 0.0198. Add the bottom together, then do 0.0099 divided by the bottom, and you should get approximately 0.33. So that means 33% will be our answer. So there's a 33% chance that someone does drugs given they got a positive test result. So just remember, draw out your tree. What's on the top will be your and. So this one was drugs and positive. Sometimes if it was drugs and negative, you would use these ones. If it was not drugs and positive, you would use this one. And then the bottom was positive, so we took all of our positive people. If it was negative, you would take all of the negative people. So you would take drugs and negative and not drugs and negative. And that is how you do conditional probability.